Hello there. My name is Amir. I'm a senior game developer at Omek game studio, and I'm here to talk about motion games, how to develop them, and how we do it in Unity by using Omek SDK. But first, I would like to show you a game we've been working on in the last few months, just to show you what it's all about. And this game is called, I hope, okay. Not very good. It's not bad resolution, probably. Okay. So this game is called Adventure Park. We have been producing it for Edu, which is a Chinese console manufacturer. And the game is basically an adventure game, action-packed adventure game, where we play a family, a superhero family, which fight the notorious evil master who has taken over an adventure park. And we have to stop him from taking all over the world. And now I'm going to play a level here where we chase this evil master. And this is an on-rail level, meaning that we actually advance in the level automatically. I don't have to move forward or backward during the game. I just advance automatically. And all I have to do is to avoid what evil master is throwing at me. He throws obstacles, he shoots at me, and sometimes he hands his minion, and I have to fight them. And let's see what we have here. So we have this cutscene. And now we start to play. So I can move side to side while evil master shoots at me. I can collect tokens, miss this one. And I can jump sometimes above his obstacle. Here I collect this token. I can shoot at him or shoot at his obstacles. Okay, and now I want you to notice some element in this motion game I have. So I have body tracking, where this character is pretty much doing what I am doing. I spread my arms, and he's also spreading my arms. Okay, but the legs, if you can see, if I spread my legs, he doesn't do it. That is intentionally. If I jump, the game actually recognizes that I'm jumping. So, damn, I died. Okay, if I jump, so the game recognizes that I jump and perform a specific animation, and you also stop the tracking animation, this body tracking. And last thing are when I go out of frame, for example, too much to the side, so the game reacts with pausing, and that's about it. You can see it's hard to control. I'm looking aside. Okay. So I have this image on the side that tells me where I am. And notice also another feedback, which is the player mask that you can see on the bottom right, where you can actually see me. So I can see where I'm placed in relative to the camera, to the depth camera. Okay, and I will exit the game. I will do this gesture. Go to main menu. And I will exit the game. It doesn't like me. Okay, I will exit anyway with the simple way. Okay, so just a few words about Omek I have to give them. So what Omek does is not completely about computer games, but its main practice is to provide a middleware and tools for motion applications. The middleware is the software layer between the low layer of the camera, the depth camera API, and the user, the developer application level. And this middleware provides all the needed functionality like body tracking and gesture recognition for the application. And another tool is the Beckon gesture authoring toolkit, which allows us to build new gesture, and I will talk about it more a little later. Omek tools work with major depth cameras. There are a lot of cameras in the market. You probably heard about Kinect camera or PrimeSense. but there are a lot of other big manufacturers like Panasonic and PMD, and each camera has its own cons and pros. Some work on daylight and different ranges, and Omek tools pretty much work with all of them. And it works on a wide range of platforms. So if you want to develop on a normal PC, or whether you want to develop on a chip, embedded your application on a chip, whether you want to develop on different OS like Linux, like Windows, and whether you want to use your own favorite language like C, C++, whether you want to develop to Flash and Unity. And of course, we have our game studio. We have been developing games on Unity for over a year now, and we have some experience on it, and we have developed a package that over the year it grew. And I want to show you our package and some example on how we create games. The examples are not specific for a single game, but are general and can be used in different games. And these are the key elements of motion game that I'm going to talk about. You have seen this in this demonstration right now. The first is body tracking, gestures, player selection, which is when we have several players in front of the camera. We have to manage them. We have to say to the first player, you are now playing, and then to the other player, you are next. So we have to manage the player. We have to know that we have all the players, and we have to select all the appropriate candidates for players. We have user interface with a whole full topic of game design, how to design an intuitive UI. And all of these, the player selection and user interface, are controlled by player events, like if I go outside the camera frame, so I have a specific player event that tell the application that the user has gone too far, and the application has to according appropriately and show this notice for him to return back. So we're going to do a hands-on session. I'm going to show you an example in Unity. Basically, I have a project here, a scene. Let's run it and see what happened. We have Andrew, which runs in an obstacle course, and he doesn't do much. He just runs, and when he tackles a stone, he just slows down. And the target is to make Andrew run side by side and be able to collect tokens or something like that, and to be able to jump. So basically, we're going to make this game more like the adventure park game. So how our scene looks like: we have the environment, just static object, lights, main camera, terrain, not really important. But we have the important object is this waypoint follower, which Andrew actually runs. It's a character controller that runs with this waypoint follower controller after some waypoint that are spread in the level. So we have this node with this controller and character controller. We have under it an empty node. I'm going to talk about it a little bit later. And we have the model. Model with some animation. We have the jogging animation played automatically on start. So the first thing I want to do is just to add the Beckon manager, which has 3 responsibilities. The first and important one is to perform initialization in front of the camera. And the other 2 are managing our gestures and the alerts. So I specify which gesture I expect to find that the player will do, like jump over here. And I have a lot of alerts here. And another thing that the Beckon manager has is player manager. So it's a simple script, actually. I've added here. When, let's see this line. OK, so I'm looking at the player manager. It just checks whether an alert is active, and the specific alert here is player enter. So if a player enters the camera, I just add a player into a list of available players. And if I have this alert where the player lives here. Oops. So I just go and remove all player index from this list. So pretty simple. Okay, and this doesn't do much. So if I want to do something, let's add body tracking. To add body tracking, I just simply add a component, a tracking animation, and it pretty much comes with default values. So let's just check it out. Let's see what happens if I now run the game. So I have tracking, but I also have leg tracking or not. Okay, I have leg tracking. Okay, but it doesn't look very well because I'm pretty much look as I'm floating on the road and I'm not running anymore. And I really want to keep this Andrew going and appear to be running. This. Okay, so this component is called tracking animation for a reason. That the tracking animation is because we treat tracking as an animation in Unity, and we want to add and use all functionality used by Unity, like animation blending or partial blending for several joints in this track animation. So if I want to lose the tracking on the legs, let's override the legs. It's done a little bit differently than in Unity with the add mixing component. But all I want to do is to remove tracking from hips and below in the hierarchy. So I don't want to animate the joints of the hips, and I don't want to animate the children. But if we'll see under hierarchy, it's skeleton hierarchy, I have the hips. And so the left hips are the legs, left leg, right leg, I don't want to animate them. But I want to animate the spine and above. So I will tell him to take the spine dummy, and animate its children, and that's all. So what other parameter we have? Wait a minute, let's just check this works. Okay, so now I have tracking on my hands, but the legs continue to jog. I mean, there are two different animations working on different parts of the body. Okay, so what makes it so simple? Well, this line I have to provide the FBX file name, the file which has the skeleton. So the SDK, which actually do all the stuff here, it returns me with the correct list of joints, so I can impose them. This track animation command impose them on the skeleton during a runtime. And we have this default layer, so I can set the layer like in a normal Unity animation layer. So I have jogging layer like 0, and this track animation layer is 1. And that's it. So this makes it nice because now I can also blend other animations. And for example, if I want to jump, I can blend jumping animation that will stop the tracking animation. Okay, so now I have under running, I can reach for some stuff, but I don't really move to the sides. Oh, nice effect over there. Okay, so I want to add moving to the sides, so I will add another component, and this is why now I will put it on the position controller. Okay, this is the sidewind controller, which I've written. All the components I've shown you so far are very general and not game specific. They are not specific for this tutorial. You can use it in your own game. But this sidewind controller is specific, and I've written it for the purpose of this demonstration. But it is very simple. I mean, it's very short, okay, and it has only one function, process tracking input. And what it does is it takes the position of, wait a second, okay. a little bit easier to find it all. Okay, it takes the position of a joint, or in this case, the joint of the head, my head, the player's head, and it maps it to the game's world, and use this mapping, the new target, to put the local position of this joint. So now that I added with the proper parameters, just the world parameters of how much I want to move sideways, I can just run this game. And now I move to the side. Yep, and Andrew also moves. So now I can avoid these obstacles. Okay, nice. But now I want to trigger events by using gestures. So I don't want to write okay. Gestures are a whole field. I mean, you have to, if you want to use gesture, you have to have a gesture recognition algorithm. So many persons do it manually by writing code, and with our experiments, this is a very hard thing to do because you really have to define the gestures. So let me just go back here. Yeah. Okay, you really have to define the gesture appropriately, meaning that if you, let's say, for example, you want the player to punch in your game, so you have to define what punching is. So punching is like this motion. But so this is what you expect. You write a code that tell the player do punch like this, use the joint X, Y, Z here, and then go back and record this gesture. But there are problems with this approach, meaning that you can't really expect what the user will do. So if the user punch like this, you may miss. When you code your gesture, you may miss, or maybe if the user just use fast gesture or slow gesture, so it may be different from what you have written in your code, and it's different from what you expected. So there are many iterations to gesture writing, and it takes a lot of time, and you need an engineer to write the gesture, the code for the gesture. So this is why we have our gesture tool that allows us to learn gestures. So we can actually record sequences of players doing the gesture, and we train a database and by using the tools. So we have learned the gesture and we can use it in the game. And if new players now performing other gesture that we didn't expected, so we can record new sequences and add them to the training set. So this is why it's better to use gesture tools instead of writing them by code. And it's also very robust and very, you can reuse them in other games also. So Beckon SDK comes with a gesture library also, with a simple gesture like jump, crouch, and dodge. So now I can use them in this game. Let's add a new script. Also, again, a script that I've written in advance, which is called the jump controller. Okay, the jump controller is again specific, but there is only one line that is important here that really do something, which is this line. Is gesture active? I'm checking here whether the jump gesture is really active in this frame. And if the jump gesture is active, so now I can perform crossfade for the run jump animation, which was the summer. So, okay, I didn't say what it does. Okay, let's run it. Okay, so I have Andrew running. So if I jump now, I have a new animation. And it's really a blending animation. I mean, if I spread my arms, I perform the jump seamlessly, and it's not a problem. Okay, so basically now we have a game. Let's add also some components, general components for player indication, such as the player mask. This is a full object with a GUI texture and a player mask that actually provides a texture. So now I am having this player mask as a texture on screen using a GUI texture, which is a good indication for the player to tell him where he's standing in relative to the camera. Okay, there is another. Okay, I can also add a simple alert notifier that I've written here that just read some alerts. If I get too close, will show just up. I get this rectangle. Again, it's simple. I've written this object specifically for this tutorial, but it is very simple. It just checks. You can see. This is the script. It just checks 2 alerts, and that's all. And set enabling of textures. Okay, so we have a game. Let's see something else. Let's see the GUI. Now, okay. Now I hope it's okay. We have a simple GUI. Currently, it just have a toggle button, and I have a regular button. And I didn't use the GUI button, because it has problems. It doesn't provide you with the state of the hover state. So I took this button to our examples from the Unity community site, which means that they use the messages of on mouse down, on mouse up, on mouse exit from where the mouse cursor goes up on a GUI element, and they change the state of the button. Well, this is a good thing now because we can actually send these messages ourselves in our GUI framework. So first, let us add to the scene a mouse manager, which is a component that deals with the tracking of the mouse. It has many features, so I can now have a cursor, or not. Wait a second. I forgot to add the Beckon manager here also, so I didn't initialize the scene. Okay, so I have a cursor, but it doesn't really interact with the button at the moment. I don't get the hover. This is because it's not the mouse cursor. It's just a GUI texture that I put it in the scene. To make it interact with the buttons, I have to add some components over here. So on every button or every GUI element, I just want to add some proxy component that will send these messages on itself. So the GUI proxy component, okay, here it is. Just have to add for every button this component. This is a general component. And now I'm having hovering. Okay. Also, by the way, the mouse, okay, it can, okay, I'm now left-handed. I can control with both hands. Okay. This is toggle. Okay. And if you think it's tedious to write and put all these components on the button, let's remove it. You can always write a script. I mean, this is what we do. We have, let's say, prepare GUI. So I've added these components automatically. And that's actually finishes my demonstration here. Yeah, we talk all about, okay, we talk about alerts. Let's skip. Okay, one of the main challenges of mouse that made us write this mouse manager are that we have to handle different events and we have to handle smoothing because tracking is not always smooth. And for mouse, you really want a smooth motion. So the mouse manager deals with all of it. Okay, so I'll wrap up this demonstration with just telling you that all the motion technology is very young and the field is emerging very fast. Motion applications are not fully explored yet, and new ideas comes up every day now, and new applications just are being developed very rapidly. So this is where Omek tools comes and help you to provide your application very fast, to create your application very fast, as I've shown you here. And I hope if you are interested, Omek provides free evaluation license. You can just come to me, or Elliot here is our biz dev over there, and ask me question. I'm just a game developer, so I can probably tell you technical stuff, and Elliot can tell you about business stuff, etc. And that's about it. Questions? Yeah.
What is the device you're using right now?
I'm using a depth camera, a PrimeSense depth camera. Yeah.
Can you talk a little bit about the cost model? Is it per license? Is it one fee for the package?
I think you better come later and ask. Basically, we provide free evaluation. I don't know the cost of our SDK. The package is not yet available, but we are working on it and to make it available very soon for Unity. And that's about it. Yes, more questions? Yes?
How many joints do you give?
The SDK itself provides, I think, 18 joints. Neck, head, torso, hips, legs, and for the hand, the shoulder, the arm, and the hand. But when you are impose the joint position on the skeleton, you can specify a skeleton with any number of joints because we do retargeting. So you tell the SDK how many joints you have, and you use some kind of IK to convert these 18 joints to a full character with different proportions also. You don't have to keep a human proportion. You can do it on, I don't know, exaggerated elephant size skeletons or mouse size skeleton, etc. Yeah.
Can you support seated players?
Seated players? What are sitting down players? Yeah, there is a mode of sitting down. There are less joints in this mode. I mean, there are the hands and the head, and not the legs. But it's something that we are still developing and working on. Yeah. Yeah, over there.
You separate like upper body from lower body in terms of gestures?
Yeah, yeah. When you learn a gesture, you can specify which joints. Actually, it can come automatically. So it can recommend which gestures have the most impact on your gesture. But you can specify also manually which gesture do you want to learn. Yeah. Yeah.
Can you publish the cam as a webcam?
With a webcam, no. It uses only specific depth sensors, cameras that provide a depth information, not RGB information. I will return to you because someone. Okay. Yeah.
How easy is it to connect up to a camera? I didn't see the process that you used. Is it just?
I just connect the camera.
You have the driver plugged in then?
The drive, you have to install the drivers of the camera manually. Like if you have PrimeSense, installed PrimeSense drivers. And then if you want to publish a game with Omek SDK, so you just have to copy more DLLs and ship it with your game. But that's about it. Yeah. Yeah. At the moment, no, but we are working on it, so there will be 2 joints. It's currently not a very big issue for us. Yeah.
Does the SDK give you access to the color depth video streams?
Yeah. So if your camera, there are some cameras that don't have RGB stream. So for them, you don't have it. But if you have RGB stream, yeah, so it gives you access to the RGB also. I didn't understand.
So, like, will it only return an image per refresh rate of the camera?
Yeah, yeah, it's an image. It's not a video playback, if I understand correctly. I think the sensibility is, I think, 5 centimeters. I think if you move, there are also jittering of the joint, so sometimes you can get noise, but 5 centimeters should be enough. Yeah, okay, we don't have. Yeah, yeah, okay. Thank you very much, and again, you can come to and ask me questions, or Elliot.